That flicker, subtle and nearly invisible to the eye, caught the attention of astronomers scanning the cosmic ocean. It wasn't just a dimming of light, it was a message hidden in the wavelength, a cosmic whisper encoded in starlight. Scientists paused. Instruments recalibrated. Data poured in. From that whisper came a signature, an invisible fingerprint of something astonishing. Dimethyl sulfide. DMS? A molecule that, on Earth, tells a very specific story. Here, it rises from the oceans, created not by storms or volcanoes, but by the breath of life. By tiny plankton, drifting beneath our waves, exhaling this gas into the sky. To find it light years away, on a world orbiting a dim, distant star, was like discovering a familiar voice in a foreign land. The James Webb Space Telescope had seen it. Or at least, something that looked like it. A possible biosignature. A chemical hint. A new beginning. Not proof. Not yet. But the kind of anomaly that demands attention. That invites questions bigger than science. If true, it could be the most important discovery in human history. The scent of life. From another world. The planet's name. K2-18b. It doesn't roll off the tongue like Earth or Mars. But within those letters and numbers hides a mystery, and perhaps, an ocean. Discovered in 2015, this world orbits a red dwarf star in the constellation Leo, over 100 light-years from us. It's larger than Earth. More massive than we are. Wrapped in clouds and gases unlike anything here. Yet somehow, despite all its alien features, it lies in a place scientists call the habitable zone. A region around its star where temperatures could allow water to remain liquid. Where oceans might churn. Where rain might fall. Where something could swim beneath the surface. In 2019, the first signs of water vapor appeared in its atmosphere, an exoplanet milestone. And now, in 2025, we see more. Methane. Carbon dioxide. And maybe, just maybe, dimethyl sulfide. All the ingredients that make scientists lean forward in their chairs. But K2-18b is more than just a rocky ball in the dark. It may belong to a new category of planets, a class with a name that blends chemistry and possibility. Hycean? A word born from hydrogen and ocean. Imagine a world where thick clouds swirl above an endless sea, where no land breaks the horizon, only vapor and wave. A planet wrapped in a hydrogen-rich atmosphere, insulating a deep, liquid ocean below. Warm? Stable? Hidden? Too massive to be Earth, too small to be Neptune, yet not gas. Not ice. Something else entirely. A new kind of world. And there may be billions of them. More common than Earth-like planets. Easier to detect. Easier to study. And now, possibly, easier to search for life. Because with thick atmospheres, these worlds reveal more in their light. More in their breath. K2-18b might be the first Hycean world we've seen up close, if spectral data can be called close. Its layers are imagined, but informed by physics, and what's there might be life. Among the expected gases, methane, CO2, water vapor, something unexpected lingered. A strange signal, around 3.3 microns. Not noise. Not error. A match, possibly, for dimethyl sulfide. It drifts from oceans into clouds. It helps shape weather. It is not found in volcanoes. Not in rocks. Not from random chemistry. Its presence, in a distant atmosphere, would be remarkable. But it's not yet confirmed. The signal is faint. The data is young. Still, even as a possibility, it changes the way we look at this world. It changes the questions we ask. Because now, we're not just looking for planets that can host life. We may be seeing one that already does. A world where biology may be shaping chemistry, as it does here. Where something beneath the clouds is alive enough to leave a trace. We are at the edge of knowing. And with each pass, every 33 days, K2-18b offers another glimpse. Another opportunity. To learn. To question. To imagine. Because somewhere in that hydrogen sky, something might be breathing. But what if we're wrong? What if this signal, this delicate trace of DMs, is not from life, but from something else? Something unknown in chemistry. Something alien in its silence. That's the frontier we now face, not just space, but uncertainty itself. A molecule is not a message, but in the vast emptiness between stars, it might be the closest thing to a voice. It might be nature's way of asking, are you ready to understand? And so, the questions grow louder. If dimethyl sulfide is real on K2-18b, who or what made it? Could life exist beneath a hydrogen sky, in a pressure-heavy ocean no human has ever seen? Not life like us, no forests, no birds, no cities glowing in the dark. But microbial life. Ancient. Alien. Patient. Living in the depths of an ocean warmed from within, shielded from radiation by clouds thicker than any on Earth. And if it exists, what stories does it tell? Not through language. Not through machines. But through chemistry. Through balance. Through the quiet rhythm of existence. Life that breathes differently, grows differently, but leaves behind a mark we can read from 100 light years away. This is no longer science fiction. This is spectroscopy. This is mathematics. This is the sharp edge of discovery. And it's only the beginning. Because the Webb telescope sees more than light, it sees possibility. It has rewritten what we know about stars, about galaxies, about time itself. And now, it might rewrite what we know about life. But the universe is careful with its secrets. Confirmation requires patience. Years of data. Peer review. Debate. Skepticism is the gatekeeper of truth. And still, hope remains. Because this isn't the only Hycean world. There may be hundreds in our galactic neighborhood. Worlds with thick hydrogen atmospheres. Worlds warmed by their stars. Worlds that speak with light and breath and shadow. And if one has life, then more might follow. The odds shift. The silence feels thinner. Maybe we were never alone, only early. K2-18b becomes a mirror. Not of ourselves, but of our questions. It reflects what we seek. What we feel.